What if we told you there are stars out there so big they defy belief? Welcome to our channel, and today we'll show you what the largest star in the universe actually looks like. But first, let's look at some of the other massive stars that have been discovered by NASA's new James Webb Space Telescope. These red giants are known as population 3 stars, meaning they were some of the first stars born in the early stages of the universe around 100 to 250 million years after the Big Bang. Because they are so old, astronomers have nicknamed them fossils as they preserve conditions from the dawn of the cosmos. Their light also helps scientists measure how the universe has expanded over time. The light from these stars is stretched, shifting them further and further towards the red end of the spectrum. This phenomenon is called redshift, and it's one of the main tools astronomers use to determine how far away an object is. But studying these stars has proved difficult because they are incredibly faint, and the universe is vast, making them hard to spot. However, with the help of JWST's mid-infrared instrument, we can finally get a glimpse at what these ancient stars looked like and learn more about the building blocks of our universe. It's worth noting that the oldest stars we have ever discovered so far are actually not population 3 stars. These are two extremely old stars in the NGC 63334 stellar cluster in the Scorpion constellation. These stars formed 13.5 billion years ago when the universe was just 780 million years old. One of the first things JWST studied was this star known as WR12, located in the Large Magellanic Cloud, a small satellite galaxy of our Milky Way. The star is 8,000 light-years away and is almost 20 times larger than our Sun. However, this is not its most interesting feature. Unlike most stars in the universe which fuse hydrogen into helium in their cores, WR12 has already exhausted most of its hydrogen fuel, and now it fuses helium into carbon. As a result, it has lost a huge amount of mass and is only 10 times heavier than Jupiter. Also, since it has shed so much mass, it is no longer round but has an unusual shape. Its equatorial diameter is 10 times larger than its polar diameter, giving it the appearance of a giant pancake. Scientists believe this shape may be due to a binary companion star's gravitational pull distorting the star. If this is the case, the companion star could help scientists calculate WR12's exact mass, something that has so far proved impossible due to its irregular shape. Studying stars like WR12 will help astronomers understand what happens to stars like our Sun after they exhaust their hydrogen fuel. Currently, our Sun is halfway through its main sequence stage, meaning it has around 5 billion years left before it starts to shrink. So while it might seem strange to be looking at stars like WR12 for answers, it's important to remember that in space, time is the ultimate perspective. Next, let's look at another fascinating area where JWST has been peering into the past. There are 3 main ingredients for star formation: gas, dust, and gravity. Stars form when vast clouds of gas and dust collapse under their own gravity. Eventually, the core gets dense and hot enough to trigger nuclear fusion. However, while we know the basics of star formation, the exact details are still a mystery. Astronomers don't know how matter goes from being part of a diffuse cloud to forming a solid body, or how energy is transported through a baby star, or what triggers the initial collapse of the cloud in the first place. With JWST, scientists can observe never-before-seen details of stars as they are born. They can see through the dust and gas that obscure our view and study the conditions that exist before, during, and after star formation. By shedding light on these processes, scientists hope to learn more about how the universe evolved and how life formed on Earth. Take, for example, this image captured by JWST of what appears to be a cosmic mirage. This phenomenon occurs when light bends around a massive object, similar to how light bends around a hot air balloon here on Earth. In this case, light is bending around a massive young star known as a protostar. Since the light is distorted, the objects behind the star appear duplicated and stretched. The smaller objects in the background are likely protostars as well. By studying these phenomena, astronomers can better understand how light behaves around these massive objects. They can also use this knowledge to study exoplanets and search for signs of life. For example, by observing how light bends around a star, scientists can estimate the mass of any planets orbiting that star. They can also look for small changes in a star's brightness, which can indicate the presence of planets passing in front of it. While it may seem like a long shot, one day JWST could help us find another Earth-like planet. And who knows, maybe it will even discover signs of intelligent alien life. It's amazing to think that there are stars out there so massive that they defy belief. What do you think? Let us know in the comments below. We hope you enjoyed this video. If so, be sure to follow for more updates on everything aerospace industry and interstellar discoveries. That's all for now. We'll see you next time. Here are some more videos we think you'll like. Did life really begin on Saturn's moon? Titan, NASA's Jet Propulsion Laboratory, has shared new insights into the origin of the solar system's building blocks. New research suggests that rather than forming within the sun's scorching embrace, many of the elements crucial to life assembled in the chilly outer reaches of the nebula, far from the heat of the nascent sun. These elements, including methane, ammonia, and water, are considered fundamental to life as we know it. Now, the prevailing theory suggests that the sun formed first, with its powerful gravity pulling in surrounding material that coalesced into the planets. However, the sun's intense heat would have broken down organic molecules, making it unlikely that the building blocks of life could have formed there. Instead, the team proposes that the elements essential to life formed in the colder, darker outer regions of the nebula, protected from the sun's harmful radiation. Water, methane, and ammonia could have combined and reacted to form amino acids, the building blocks of proteins and other complex organic molecules. Once formed, these molecules could have been incorporated into meteorites that rained down on the early Earth, seeding our planet with the building blocks of life. Scientists are now eager to test this hypothesis, searching for evidence of these organic molecules in meteorites and exploring the possibility that life may have arisen from extraterrestrial sources. The discovery of these enormous stars and other celestial bodies is helping scientists learn more about the universe and our place in it. From the oldest stars to the building blocks of life, there is so much to explore and learn. So keep following along as we continue to uncover the secrets of the cosmos. Next, let's take a closer look at one of the most exciting recent discoveries made by JWST, the largest star in the universe. Dubbed the Cosmic Onion, this massive star is located in the constellation of Eridanus and is almost 900 times larger than our Sun. However, it's not just the size of this star that's impressive. One of the most remarkable features of the Cosmic Onion is its unusual shape. The star is highly elongated, resembling an American football rather than the more typical spherical shape of most stars. This unusual shape is thought to be the result of a collision between the Cosmic Onion and another star, which has caused it to spin rapidly and form a disc-shaped structure. But the most surprising aspect of the Cosmic Onion is its age. Despite its enormous size, the star is only about 10 to 20 million years old, making it a red hypergiant. This means that the star has already gone through several stages of stellar evolution and has a relatively short lifespan. In fact, the Cosmic Onion is thought to have only a few million years left before it explodes as a supernova. When this happens, the star will release a massive amount of energy and light, creating one of the most spectacular events in the universe. The explosion will also create a large amount of heavy elements, such as iron and gold, which will be released into space and eventually form new stars and planets. The discovery of the Cosmic Onion has provided scientists with a unique opportunity to study the life cycle of a massive star. By observing the star's unusual shape and characteristics, astronomers hope to learn more about how stars evolve and explode. They are also eager to study the star's composition and look for signs of heavy element production. Overall, the discovery of the cosmic onion is an exciting development in our understanding of the universe. This massive star's unique characteristics are providing scientists with a wealth of knowledge about stellar evolution and the life cycle of stars. And as the star continues to evolve and eventually explodes as a supernova, it will undoubtedly be a source of fascination and study for astronomers for years to come. If you enjoyed this video, please hit the like button and subscribe to our channel for more exciting updates on space exploration and scientific discoveries. Thank you for watching, and we'll see you in the next one.